If I were to ask you to think about a pipe bursting in your home, your first thought may be, what a mess, or I hope that never happens to me. Your first thought probably wouldn't be about brain cancer. But what if I were to tell you that brain cancer and bursting pipes have a lot in common? Cancer has pipes too, except in cancer, these pipes are called blood vessels, and they're very leaky in nature. So I asked you to picture that you're sitting in your downstairs living room, and all of a sudden, you look up, and oodles of water start pouring through the ceiling from a pipe that burst in your upstairs bathroom. Now, I ask you to picture that this fluid is not moving into your bathroom, but instead into the tumor. And from the tumor, it moves into the surrounding brain instead of your living room. I care about this fluid, but why should you care? You should care about this fluid because it's this fluid that increases the movement of cancer cells from the primary tumor into the surrounding healthy brain. And this movement of cancer cells, known as invasion, makes survival less than 2 years for nearly all brain cancer patients. The purpose of my thesis is to study this fluid. It has 2 parts. First, using MRI, a common medical imaging tool, I can non-invasively visualize this fluid in the brain. By taking a series of images over time, I can determine the rate of fluid movement and the location to see if either contributes to worse prognosis for the patient. For example, a pipe bursting in your living room may be less detrimental than in your office, where you have all of your important documents and technology. Second, I wish to know why and how these cancer cells move with the fluid. There are certain cancer cells that are more likely to move, based on properties they inherently express, similar to your or my personality. If the fluid in your living room is carrying your most prized possession, you'd be inclined to go with it. It's the same for these cancer cells. The fluid is carrying molecules that make them want to move too. So I add these cancer cells into a gel that mimics the natural brain. I characterize their personalities and the composition of this fluid. I then expose them to different rates of flow, and then using microscopy, which is an instrument that allows you to see very small cells with magnification, I determine how and why and which ones are moving with this fluid. So if we can visualize this fluid in the brain and then understand why they go with the flow, we can develop new treatment strategies to target their movement and prevent their invasion into the surrounding tissue, and hopefully increase survival. Thank you.